Same portion.
Yeah.
What is the portion?
Water.
How much of water?
Second part. Yeah.
Second part of okay. I'll do it online. Okay, from
When?
on Sunday.
Sunday.
11 o'clock, 12 o'clock. I won't come here. I'll do it online. So then you just can you send me the message saying that you give the link. I'll do it. Yeah. It's the first lecture of the day, no? Yeah. Where is the line? One moment. So that is one thing. Okay. Yesterday he came for class? I didn't came for class yesterday? Yes. In time he came?
Yes.
Ah, really, sir? Why you late? Huh? Huh? I mean, you don't have to, so what you pay to fully again the work you You pay to something. Every time you did that, how much did you pay now? 34 rupees and he allowed you to go without taking any money from you? Why did you do this?
I told him that I was going to pay.
Same same water, last time auto only. I don't have KTM. Yeah, hello. Hello. He has come just now. Again, he's come. He's taken the auto and not paid the auto. 34 rupees has to pay. 34 rupees has to pay. Okay, don't worry. I'll do that.
The auto driver didn't have change, so I have to pay him later.
Handle the Paytm. Has handled the Paytm.
Hello?
I can't see anyone.
Send a message to me.
Ah. You pay later, okay? Because I don't have Paytm. I got cash. You pay him. Can I take he is with me? Bring him home. No, he comes at 6 o'clock. I'm leaving at 2:15. I can't bring him home. Chalo, bye. Bye. Come, go sit down. On this line, cash. Achha, so that is done. Your problem is solved. So your problem is sorted out. 11 o'clock. Let me know what the link is and yeah, let me know what the link is. Yeah. This is much better. But still, sleeping is still there. But okay, if you really get this, do it like this. Let's say that you have 1, 2, 3, 4, 45 words on alignment, not more than that. Okay? Yeah. Stand. Okay, that is one thing. Hurry. This girl is absent 10.
Yes.
And another girl, 11 of you are there, no? In the class.
Yeah.
Who's
She
that
will
one?
be, Madhurima will be absolutely 7.
Oh, Madhuri.
One of the girls, she used to say, yeah, just at my place.
Another thin girl, no?
Yeah, even Madhurima is 2 girls are absent. Yeah, there's 2 girls.
Here they are marked 3.
Even
Krishna Yadav, who's Krishna Yadav?
from
Hello. That fellow too. Irfan, Sarina, Kuchi. Yes, I know that one. But she has been coming quite some time, that girl, Madhurima.
No, she came last. Not last class, I was absent. She was absent.
You were absent also last class. Now we come to, okay. Now, so that was one thing I sorted out to let me know exactly. And log in on time. Huh? Don't log
Like,
in.
where do you have to message?
No, you have to tell Dwarka ma'am that we will take the class online. Okay, just tell her, we'll take the class online. Okay, then someday she'll leave the Alright, then alright, another thing is children, when you are representing the electrons in the first shell, suppose this is now here, for example, protons here, neutron plus neutrons are here, okay, and then this is the nucleus, and this is the first shell. I had told you that you have to put the two together.
You said that area the fearsome is safe.
This is the one, this is the one, okay, this is the one. Do not put them together, children.
You have
Put them like
up
this.
and down.
Environment. Okay, that is the way. Opposites. That is the way. For only the first shell. Because what happens is when you put them together, it means they are lone pair. Then that gives a different connotation altogether. You can do it for other shells, second, third, fourth, and so on. But for the first shell, there's not a lone pair there. They're two different individual electrons. Therefore, they have to be kept one opposite the other. Correct? That's the concept. That is what I wanted to clear up. Now, then I checked up with these people. Now we come to periodic table. Last time I have mentioned periodic table with you. And what did we do, children? We finished with Dobereiner's law of prides. Do you know the law of prides? Law of prides. Who can tell me law of prides? There are
three elements in one group.
how are we? This randomly they pick us
By the atomic weight.
and what else? They are arranged according to their atomic weight means what?
Weight of the atom.
Increasing.
Weight.
And what else?
And they calculated the middle one.
Another characteristic, another distinguishing characteristic. Atomic weight, increasing atomic weight, and another thing. What's the other thing? Two things go together.
That can be
Similarities in the chemical property, similarities in the chemical or physical property, any chemical. What happens then when you got this triads? What happened? What was the characteristic there?
they calculated the weight of the middle one by adding the first one and the last one by dividing by two.
Adding what on the first?
The atomic weights.
Atomic weight. They roughly, approximately calculated the atomic weight of the middle element by taking the average weight of the first and the third. Now, why did this collapse? Why did this rule collapse?
Because there were too many elements to fit in, he only had made 9.
He had grouped only 3 sets, but it could not be applied to higher atomic weights. Next came, who followed next and after that? Who followed next after that? After Dobereiner, who's next one? Who followed next?
Manually, middle,
Who followed next? Who? Anaya?
manually.
Not who else? Who followed next?
Newland.
Newland, yeah. What was his law?
Law of
Law of what was the law of octaves? What was the law of octaves? Do you know?
the last and last eight.
No, that is octet rule. Octet is not to be mixed up with octaves. What is the octave rule?
It's the arrangement.
You let this boy answer. You know Ian? Yes or no? No. Who knows? Yes. Anaya?
Arranged according to the increase in atomic mass.
And what else?
Every 8
What? Do you know?
element starting from any element that
I didn't ask you to read. I asked you to tell me orally. Do you know? You.
Like the first, like the 8th element had similar chemical and physical properties as of the first element.
So there was a repetition after a period of 8. Right? Now, why did this law collapse? Anyone?
Because we couldn't classify after chlorine.
After calcium. It could not be applied for higher atomic weight. What else? What is the next drawback in the case of Newland? In the case of Newland, next drawback.
The highly reactive metals and non-metals were coming together.
No. You put the wrong element in the wrong box. Then you put atomic weight of a higher atomic weight before the lower atomic weight. And it was supposed to be the other way around. So these were the reasons why they collapsed. So who initially took after that? Mendeleev. Why is he called the father of the periodic table? It's a book.
because he left We left spaces between some elements.
Huh?
He left some gaps between some elements.
No, I asked you what was Mendeleev's law. What was his law? That is very important. You have to learn Mendeleev's law word to word. Ad verbatim. What is the law? What is the law? Law. Who can tell me the law? Who can tell me the law? The law states that the chemical and physical properties of elements are periodic functions of their atomic masses or atomic weights. Correct? Alright. What's mean periodic? Periodic, which is you can tell me, give me a periodic.
Generally, on terms of this,
It can be applied both ways.
like, generally it's after a change occurs there.
Yeah,
After
periodicity
certain
means-
years, intervals of time.
Yeah, periodicity means when a particular phenomenon keeps on repeating at regular intervals of time, then the cycle show periodicity. In the case of Mendeleev's periodic table, what was the periodicity that was being exhibited by these elements? Yeah. No. What is it? Whatever they showing, they were showing regularity in their chemical and physical properties. They were showing regularity in their chemical and physical properties. Correct? That is very fine. What were the drawbacks of Mendeleev's periodic table? Were there drawbacks? No drawbacks?
They thought they were drawbacks, but they
Okay, initially, when they thought that what were they?
left empty space.
Correct, we left empty spaces. Okay, then
We did not leave positions for isotope.
for isotope, what else? The probability existing even till today,
No space
There's
for
no place for
hydrogen.
no practical definite place for hydrogen. Okay, now, were those difficulties overcome?
Yeah.
In the modern periodic table?
One
How was it?
when we left spaces,
Yeah,
that time only I think 26 or
63.
63 elements were discovered. There was no element which resembled both of
Which had similarities in the
So
properties of
then
aluminium.
after some years when he
Yeah.
died, that type of element was discovered and that was used.
Yeah. So in case of aluminium, he made empty space. What do we call it? Empty space. What do we call it otherwise? Sanskrit name was given. Eka aluminium. What filled up that place there?
Gallium.
Gallium. And what was another empty space again? Eka what? Silicon. So what filled up that place there? Germany. What was the next one that was left? Eka what? Oh, eka silicon is germanium. That's what we said just now. What else? Eka boron. What filled up that place? Scandium. What filled up that space? Scandium. That's not like the textbook. Write it down. Kids, write it down. Eka boron was filled with scandium. Eka boron was filled by scandium. SCAN, scan. SCANDIUM, scandium. Eka boron was filled with scandium. Okay, so you got all that, right? Correct? So that is what is your whole period. Then how were these discussed? How were these effects overcome? How were they overcome?
When new elements were discovered,
When no. How were these fights? Yeah.
Like scientists told to arrange the elements by atomic numbers and
Not scientist, only one scientist, and Henry Moseley. He changed over Mendeleev's periodic table, which was focused on atomic weights. He said no, not atomic weight, but make them atomic numbers. Why did he use atomic numbers instead of atomic weights? Yeah.
because the atomic number of each element is different, while the atomic masses can be the same.
Yeah, but many elements can have the same atomic mass, but atomic number is a very distinguishing characteristic of any element. It is an identification. So he said that now we have to rearrange the wording of Mendeleev's periodic table by saying that chemical and physical properties are periodic functions of their atomic numbers. Okay, and when we focused on numbers, automatically isotopes got the same number, same place, because both of them belong to chlorine, whose atomic number is 17. Both of them, whether it's chlorine 25 or chlorine 17, chlorine 37 or chlorine 37 or chlorine 35, both of them will be kept in the same box, because both of them belong to chlorine, atomic number 17. Okay, so you have to give separate places for isotopes. Secondly, what we said that when we said that atomic weight of cobalt is more than that of nickel, and it is kept before nickel, but we found that atomic number of cobalt is less than that of nickel, so that place was fully justified. Okay, because number is less, cobalt atomic number less than nickel. Atomic weight may be more. But according to the modern periodic table, since we are reaching according to increasing atomic numbers, that position, that so-called defect in Mendel's period was rectified. Okay, so now we have got it. Alright, now we come to the study of the modern periodic table. Now, if you own, all of you, when you're studying the modern periodic table, you've got to open up your periodic table. Oh, you have to open up this paper. Or if you open up this page. This page, right? I want to say actually why it's in your book. Like,
Two bundles left. Around.
books, when you take out the money, you don't take the box in the money.
I just put in my bag.
Okay. Now what happened? So, yeah, now look at this, children, look at this periodic table. Now, all of you, can you see the blue portion? Can you see the blue portion? That is starting from scandium 21. But that scandium 21. You cut it right down to UNO. UNO, cut it out. UUO, cut it down from UUO, right up to UUO. Scandium to UUO. Otherwise, no, don't go there, don't go so far away. You cut it out from scandium, that is 3B, right up to 2B, right up to 112. Copper, nickel. Copper, nickel. Copper, nickel, cut out. From 3B to 2B, cut out. Up to 2B. Both ways. Put a cross. Now, alright, so that means that particular portion is not in your course. Okay, now pay attention very carefully and not going to repeat. Look at it carefully on the paper. Now, if you cut out all the B, what is left on the table now? A. So imagine the 3A coming straight away after 2A. So that periodic table has been shrunk. Yes or no? Can you imagine it being shrunk? Shrunk. The empty space in between is taken out. Why have I taken it out? Because those elements are not in your course. The B is not in your course. You have only A in your course. So how many A's are there now? How many A's are there? 8 A's. Can you read 8 A's? How many A's are there? 7 A's. Okay. 0 is there. Keep it there. Now, what are these A elements? Write them down. A elements are representative or normal elements. They are representative or normal elements. A are representative or normal elements. Or normal element. A group are representative or normal elements. Or normal elements. You got that now? Now, what are these normal elements? What are these representative elements? These elements, pay attention. These A group elements, as I said, are representative or normal elements. What is the meaning of normal? What's the meaning of representative? They have got all their shells complete, excepting the last shell. The ultimate shell is incomplete. Representative elements have only one shell incomplete, and that is the last shell, the ultimate shell. And the B, which we cancelled out. Put that out there. B belong to transition elements. B belongs to triangle B. B group belongs to transition, and inner transition elements. And inner transition element. B group contains transition and inner transition elements. Inner transition elements. What are transition elements? What are transition elements? No. Transition elements are those elements having two shells incomplete. The ultimate and the penultimate. The last and the second last. That's how they are different from the represented groups. That is how possible because the orbital jumps from a higher to a higher level and then comes back down to the lower level. That is the somebody asked me what about some electronic configuration of copper and iron now. It is a problem here. They are transition elements. They have got two shells in them. They have got variable valence. Now pay attention. Let us go step by step. So A group contains representative elements of normal elements. What are representative elements?
The large shells.
They have only one shell. But only is very important. They have only one shell incomplete, and that is the last shell, which is called the valency shell. What is transition element? What are transition B group elements? What are they?
The shells that have the elements that have two shells incomplete.
Which two shells?
The penultimate shell and the valency shell.
Ultimate. Penultimate and the valency is the last shell. Ultimate and the two shells incomplete. They are called transition elements and inner transition. Okay? Just remember this. What are inner transition? I will explain to you as we go down step by step. Now, so therefore now, we are in your course you have only representative elements. Now in the representative elements, the classification is very simple. 1A has got one electron in the valency shell and its valence is also 1. 2A has got how many electrons in the valency shell? What? 2A. Yes, if you are not with me. But I want the answer. What? Not like this, like this. Or like this. So what's the valency then?
2.
2. You're asking me why the frown on your face? Why the frown on your face? Come here, I want to smash you. What's the valency? Number of electrons in the outermost shell. What's the group I'm talking about?
2A.
2A. Good. 3A. And what's the valency?
3.
4A. 4 what? And what is the valency? 4. Correct? Alright. Then we come to 5 group.
5 electrons. 5 valence.
5 valency electron. What is that the same? Valency? 3. That means group number minus 3. Okay, so that means what I'm trying to tell you children, if I call out the group number, immediately you know exactly valency, you know valency group. You know valency and you know the valency electrons. Now what happens is, these transition elements came in between, and if you count them, they are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 or not? 10 in between. That's what you cancelled out. What you cancelled out are 10 now.
Yeah.
So when the 10 came in between, the B group came in between, the periodic table kept on being counted like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Because 10 came in between. So when the 10 came in between, 10 plus 8 was 18. Correct? Now, how would you like to learn the periodic table? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, or 1, 8, 2, 8, 3, 4, 8, 5, 1, 8, 2, 8, 3. Why? Why not 18, 1, 2, 11, 12, 13, 14, 5?
Because it's not like specific, like A or B.
Now, why are you saying you want to study this? Why is it there?
Because we are specifying each element to different groups.
No. Why is it easier to learn 1, 8, 2, 8, 3 rather than 12, 13, 14, 15, 16, 17? Now, why?
We are separating like the first 20 elements.
No, anyone.
So that we can understand the values.
You're right. Because when we say 1A, we know immediately that it has got one valency and one electron. But if I say 11 electrons in the valency shell, yes, then followed. So don't learn the periodic table 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No. Go as 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And 8. Zero group is 8. Okay? Now. So therefore now, pay attention to my sentence. 1A group has got last shell incomplete. Not 1A, A group. And B group has got two shells. But zero group is neither A nor B. It's only zero. Why is it only zero? Why is not A group? Why is not B group? But just zero. A and why is it called zero? Why there's no alphabet attached to it? A is not attached to it. B is also not attached to it. Why? So then why is it why?
You don't need any.
Huh?
You don't need it.
Means what?
Neon doesn't react with any other.
Give me something different. I want something more specific. Why?
Because it has 8 electrons.
Yeah. If I say it is 8A, that means one shell is incomplete, no shell is incomplete. If I say it is 8B, it means two shells are incomplete. Here, there's no. So since all the shells are complete, okay, so we don't call it A nor B. We just say 0 or 8 group. Correct? This is clear of you? Clear? Now, transition means what, children? What's the meaning of transition? What's the meaning of transition? Transition means change. Transition means change. What is the change taking place? Gradually, if you see on, now it is my left side. My left, it is also your left side. On your left side, you have all metals. Look at the look. Don't look at me. I know I'm looking very pretty, but don't bother about me. Look at the look. The ugly periodic table. So, look at you, don't take anything, look at me. So, on the right hand side, you've got only metals.
No.
On the left hand side, you've got only metals. On the right hand side, you've got only non-metals. In between, you've got transition elements. Transition elements means it is bringing about a change. It's bringing about a change from metallic character gradually to non-metallic character. That is bringing about a change. Transition means change from metallic to non-metallic. Now I am using the word, now I said on the left hand side, you've got metals, elements which are metals. On the left hand side, on the right hand side, on the left hand side, you've got metals, elements which are metals. On the right hand side, you've got elements which are non-metals. Okay? But transition are elements which are only metals. So do not say transition non-metals. No. Transition elements, but those elements are metals only. So what are the characteristics of transition elements? They are metals only. They have got two shells incomplete, ultimate and ultimate. Hence, therefore, they have got variable valency, the OUS and IC. The OUS is of a lower valency, IC is of a higher valency. And lastly, they have got all color compounds. Copper is yellow in color, copper is greenish blue, nickel is green, ferrous is green and brown. So all of them have got color compounds. So what are the four characteristics of transition elements? They are metals. They have got two shells incomplete. They've got variable valency, OUS and IC. OUS low valency, IC high valency. And lastly, their compounds are color. That is what you have to remember about transition elements. Okay? Now, if you look at your periodic table, children, now what are these transition elements that we're talking about? And what's the meaning of transition? I'll explain to you as if you are a traveler. Now see, if you're going from India to say France. In India, from India, when you leave the shores of India, You are taking Air India flight, and the first stop is Dubai. First stop is Dubai. And when you are in, pardon me?
Yes, layover flight.
Yeah, you don't have a direct flight. You have a break. Now what happens is when you are there at Dubai, you are not allowed to get out of the plane. What happens is the escalator comes and locks itself to the plane, and you get out of the plane into the escalator directly into the waiting lounge.
Aero bridge.
Yeah, aero bridge, and you get onto the waiting lounge. You're not supposed to get out onto Dubai because you don't have a visa. You are a transit passenger. You are in transit. What is happening here? You are there and you've reached Dubai at 4 o'clock in the afternoon and your flight is at 9 o'clock at night or 12 o'clock at night, Air France. You're changing from Air India to Air France. What is happening? While you are there, your luggage has been taken out from Air India and put onto Air France. That is one thing. You are changing from an Indian passenger to a French passenger, not citizen. You're changing from an Indian passenger to French passenger. Transit. Change from Indian passenger to French passenger. Meaning what? Your insurance now has shifted from Indian government to French government. If you have a problem on that train, your French government will pay you your insurance. You're in transit. Change. Not citizenship, but passenger. You're changing from Indian passenger to French. Now you're the property of the French government. So you are there in that lounge and you are supposed to be staying there till they call you at night to board the French plane, the Air France plane. Now while you're there, you want to do shopping. You do your shopping in the airport at duty free. And you have to show them your boarding pass that you're going to board the French plane. Because they know fully well you're leaving the country. You're not going to stay there. So you board the pass, you buy your liquor, your chocolates, whatever, duty free. And you buy it from a place here. God forbid if something happens, you can get it exchanged in France. So they have got connectivity. These shops here in Dubai or in India have got connectivity abroad. You can get it cheap. Once you've got the bill, you got the bill and you got the time on your boarding pass, everything can be done. No, but it's very expensive here to buy. I want to go out to Dubai and buy whatever I want to buy. And for that, you have to get a visa. So spend money on the visa. Then you think you can get the visa in 5 minutes, then you have to wait for such a long time to get the visa. You may get a visa. Okay, suppose you're a diplomat child, diplomat something, and then the car comes to pick you up. And then you go, everything is an auto. Auto rickshaw is a No, there's no auto rickshaw. You have to book a cab. And the cab will take you. You know where will take you because there's a new person in that place. Every stop you make, get paid for it. I want to buy a hamburger, I want to go to McDonald's, I want to go there. Every stop you make, you have to pay. And these taxi drivers are so smart. They got connectivity with all those shops on the road. They take you money, they're all connected, they get their money. And then if something goes wrong, that is curious thing that given you, who will exchange it for you? So we have been a foolish fool for having got out of the plane and got into that to go and buy something from the streets of Dubai. Then you have proved yourself you're a foolish fool from India to Dubai. You want to be a fool, you are a fool, keep your mouth shut. And don't open your mouth and prove and take out all doubt from their mind. When you open your mouth and behave the way you're behaving. Mouth shut, sit quietly, buy whatever you have to buy. From the airport, duty shop, and the dignity leave the place and the country. Many people do that, and they tend to be foolish and stupid. Okay, idiotic, yeah. And once when I was there sitting down and looking at so many hours are there, and I was looking out and I found many of our labor class, carrying trunks on their head. You know what trunks? Not our trolleys and VIP suitcases that travel bags, whatever we have, they have all built-in trunks, all type of trunks. And with that on top of that, they had the chatais and bundles. And they were all at the labor force. They were all taken to the sands where they have to construct and build, and they are laborers there in Dubai. So if you want to have a laborer to do some construction in your house, you advertise in the Dubai Times. You get all your labor, Indian laborers are there. It's difficult for you to get a laborer to do something in your house in India, because most of them are migrating to the Gulf. And there the Gulf people are taking use of them. Have you seen the palaces at Burj Khalifa? Who do you think has built that? Our Indians. Our Indian workforce has gone up there to build up. How many story building it is at Burj Khalifa? Such a big building. All built up by Indians. All built up by Indians. And half the floors of that Burj Khalifa is being owned by Indian businessmen and cricketers. Although, you see, if you want anything to be done in your house, advertise in the Dubai Times. You get a lot of people there. Because our workforce is that side there. That's what it was a sad thing. The way they were treated. The way they were treated. But hunger and poverty has pushed them to do something like that. Okay? So that is what I mean by saying transition. You're in transit. You're in transit. What is happening in transit? You're being changed from an Indian passenger to a French passenger. Everything is being changed now. And the government's responsibility is being put on to the French government. Is this clear? This is what happens here also. All the properties of the metals are gradually from sodium, which is the highest metallic metal. Sodium less, the next one magnesium less metallic, aluminium less metallic, carbon very less metallic, more non-metallic, then non-metallic, you go up to argon, that is the eighth group, which is highly metallic, highly non-metallic. So that is, the change is going via or through the transition element, the first one transition element. Okay? Now, look at the periodic table again. You have the first group, first period. First period has got how many elements? Only 2. Look at it, don't look at my face, look at it. How many elements are there? 2. In the N, that is K shell. First shell, N is equal to 1. Energy level is 1. It is K shell. K shell, there are how many elements? 2. How many electrons are there in the K shell? 2. So that is called the shortest period. Shortest period is called the first period. First period. K shell. Second and third are called short periods. They have got 8 each. Look over inside. They've got 8 each. Second and first is very short. Second and third are called short. Fourth and fifth are called long. They've got 18. They've got 18. Sixth is the longest, 32. And seventh is incomplete. Seventh is incomplete. That is the classification of your periodic table. Now, when you come to 3B, okay, in the sixth period, you've got something called lanthanides. And below that, you've got actinides. Those lanthanides, they are called inner transition elements. Actinide. Lanthanides are rare earth elements, inner transition. And actinides are also inner transition elements, and they are radioactive. They are radioactive. Okay? So therefore, your periodic table consists of representative elements, it consists of transition elements, it consists of inner transition elements, and it consists of zero group elements. This is your classification of your periodic table. Representative or noble elements, transition, inner transition, and noble elements, or zero group. Is that clear? All of you? Yes. Now, representative elements or normal elements are called S and P group elements. S block and P block. Why S block and P block? Because the last electron gets into the S shell, the last electron gets into the P shell. How are they getting into their shell is not in your course. But remember, representative elements or normal elements are called S group elements or they're called P group elements because their last electron gets into the S shell or into the P shell. Transition elements are called P. They're called P block elements. Transition are called P block elements because their electron gets into the D shell. And inner transition elements are called S block elements. Their electrons get into the S block. After that, it's too high. The energy level is too high for you all to understand. So S, P, D, and S with P belongs to representative elements. P belongs to transition. S belongs to inner transition. Is that clear? I will read till there. Read till there. Go right through everything till you come to types of elements. I forget it. Till you come to types of elements.
From the volume of population.
You learn from the you got Selina, no?
Yeah, they have got the
You have got the last translation from it. Read from there. The last. 82, 83, 80. You read from the volume only. Read from the volume. Come on, hurry up, start reading. Get into it. I told you.
Till the elements, but
Till where I taught you. Till here. Read. The next class I will come and complete the rest. I don't read from the land because the land is we take from the volume only. We come for duty volume. Question answer you are from Bilal.
in your book it is given something UU, and in our book it is OG. Like
Son.
in your book it's UU, the hormone and this in this it's OG.
OG put they've already gave the name now. They've given the name. Yeah, UU means what? U means unique. U means one. UU what? Oh, no? UU is what? U is one. U is one and O is octet. Octet. So 118. 118. That was general word given to you. Here now they've given you the name.
Do we have to cut out all the transition elements in the periodic table? Do we have to cut out all the transition elements? Like but only this line or like
All B group is correct. The whole of the
equal. Yeah. Ma'am, neodymium is used for magnets, right? Neodymium.
Neodymium.
Yeah, magnets, right?
Is it negative they say?
No, they don't say like I saw it in the
Maybe I really cannot say that. I don't know.
like they are like very big magnets. Neodymium.
Now in the periodic table, they haven't given the state of some elements. How would we know this?
For that,
They haven't given the state of something from matter.
from which one?
In the periodic table, some elements are not given the state of matter.
You are supposed to learn only one.
In A group also. In A group also.
Which age group? You're supposed to learn only up to this thing, no? Atomic number 23. Calcium up to 40 only. Up to calcium only you learn.
The boards also.
Yes. So in ninth standard go to what?
No, in the board.
Yeah. Still calcium only.
Be very I know. Video. Brass, nobody carry it was not scary. Brass,
Yes. 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 Hey, why are you talking? You are finished reading. Have you finished reading? I will smash you and make pulp out of you.
Mom, what is this IUPAC?
IUPAC
International Union of
International
Pure
Union
and
of
Applied.
Pure and Applied Chemistry. IUPI International Union P Pure Applied C Chemistry.
What is that?
That's an international body which will do research on whatever results they put forth and verify whether what you're done is correct or wrong, and then advertise it and accept it, and then it's you're given recognition for your research. That's a body that authenticates your research in chemistry. Now, people can write them bullshit and say, yeah, it can be done, it will be done, we have put this cover, but it has to be recognized by it has to be investigated, yeah. That's be authenticated by the board. If you read till there, work on the question and answers up to there.
There's no exercise.
There will be. If you go on to the comment portion, see whatever you can work out.
On the audio call.
Volume and Selena are the same. And there are both. You can't argue. Both.
Selena question answers are already worked out.
Not all. Some of them are there for class work. The board uses both these books, the Lal and Selena.
Just a question. The relative atomic mass of a light element up to calcium is approximately dash atomic. Relative atomic mass of a light element up to calcium is approximately dash its atomic weight. Number atomic number.
If it is even, it will be double. If it is even and odd, it will be double plus one. That's all.
So how can we write it? Yeah, because it's only one dash now. It has to count the first one.
They said light elements, no?
Yeah. Light element up to calcium.
Double.
Union from Neptune.
Neptune is from Neptune only, but it comes from that name, not from the state, not from the planet. No.
Neptune is the name of who?
Neptune
Neptune is the name
of the god.
of God.
Yeah, Greek god is Neptune.
God of sea.
Like all these has a name but Greek gods.
Pluto.
Saturn.
Greek god of Mercury.
Jupiter.
Neptune, yeah, even Poseidon. Poseidon also, Neptune is the god of the sea, of
Ocean.
oceans, yeah. Poseidon is also there, god of Poseidon.
Was Galileo Greek?
Huh?
Was Galileo Greek? He's the one who spotted all this.
Galileo was Greek, I think you
Planets.
I don't know. What difference does it make in Shakti? He was Greek, no, he was not Greek. Galileo was, no,
There's plutonium also.
Italian. Galileo. Italian.
Galileo.
Hey, sounds like Italian is something Greek.
No, I think he's Italian. Anything Italian. You check it.
That's never remains the same.
Italian. Astronomer and physicist. Oi, keep quiet now. Don't talk. Foolish children. No, Satvik, no? Satvik and Anaya. Ananya. Finish fast. I told her already that I'm taking it from home. You want it from home, no?
Oh yeah, like from 11, ma'am, but it's not possible. Like on Sundays we come here to give test, and it like we disperse it from 11. We disperse here from 11. Like
What time you have the test?
10 to 11. Like 11:50.
10:30,
So like Bhaiya said that we can join the meeting from here.
Okay, then we can get that.
Shall I ask that Bhaiya?
So I give you the link. Then sit here and watch it.
I'll just ask it.
What are you doing?
So we were discussing if there's a test.
Focus on one thing.
3 tests.
Which subjects? No maths.
Then tell them if you're finding it difficult, tell them not to keep 3 tests. Tell them finish it, inform them. It is difficult for us to parents and
Change it for us.
they will ask if your parents are putting in an application or parents are doing it, then they will do it. And they will do it.
Ma'am, I guess I don't have a test on Sunday. I don't have a test on Sunday.
You don't have a son, that's okay, so you can come at 11 o'clock, you can be there, you start, but they start to do. Which part of the bottle you want me to do, which part you want to do?
B part.
B part means what now?
Solutions.
Till which one? Solution till,
The whole thing.
this is the whole thing.
Yeah, we were not there.
How will I be able to do all that in 1 hour? Whatever I can do, I'll do that 1 hour, okay?
Extra lecture.
एक्चुअल एक्चुअल ना द्वारका ने 11 बजे रखा है फिर 12 तो 11 बजे को उसको बोलो 11:30 बजे को रखो
आप इधर आओ।
नहीं मैं उधर में हूँ यहाँ से
Sorry, तो घर से करना है.
नहीं अगर तू इधर है तो इधर से connect कर।
So you want at 11:30? Yeah?
Is it kind of
These are the most
Here's a question.
what happened?
Why are group 17 elements highly reactive? Like halogens.
That I have to explain to you that. section. Zero letter. Come on, finish fast. What will you are not writing anything?
No, I'm reading. I'm just from this and get some cross again. On the yes, it's only red. So first two are like pen. Yes.
I want it to be like
I think yes. There's a question written name and element of group 18 which can form
Noble gases. They can't
18. See, they cannot actually, but under very special conditions, you can make them work. But that from where you got it from the uranium is there, is there, xenon forms.
So we can write it down.
You don't write it down in your portrait. That question should have been asked before. Question should have been asked.
A has two states between 4. It's valid.
calcium oxide.
Is calcium and oxidizing or reducing?
Calcium
Is calcium and
is
oxidizing?
calcium a metal or a non-metal? So metals are what? Oxidizing agents or reducing agents? Reducing agents. Chlorine, remember chlorine is put into swimming to kill the germ, oxidize the germ. So chlorine, a non-metal, is an oxidizing agent. Metals are reducing agents. That you remember now.
Okay, done. Yeah, we're done.
Use the light. All this will help you out next year. Let's say you have the same thing. So you've done already so much, then you don't have to do much. Who put all that maybe on your hand? On your own?
Yeah.
So much of time you have to put on your maybe because you have about so much of time spent like chemistry.
They are stable. One minute. But like 8 days. 2 minutes.
They are given
मेरे पास तो 6 चौकी बचे
10 रुपए में 5 पेपर
10 रुपए में 5 थे।
अरे वो तो एमआरपी पे होगा
हाँ ठीक है लेना है
वो
हम लोग के पास 12 रुपए में बस कितने में पास
अरे सोचना बोलो
हाँ
लेना
तेरा खत्म हो जाएगा 12 में 5 दे देना
12 में 5 तो नहीं
अच्छा 13 में दे दो 13 में दे देना 13 नहीं
क्या
14
एक मुझे यार